So for this week's engineering design process, we were given the erosion bottles. So to start the process is we always ask the question. The question we were given this week is, what is the best land cover for a healthy watershed? And then imagine. So I used the provided simulator and the erosion bottles directions to kind of go through and prepare for this experiment. So then the next step is plan. So I used the directions as provided. I gathered all my materials, and then I kind of looked through and to see if there are any immediate changes I needed to make before even starting this. So what I ended up doing is, instead of growing the grass in the container for time purposes, I just kind of cut some out of my yard. You can see kind of here as I'm prepping everything, and then once everything is put together, I made sure the soil I used was the same spot that I got the plants from, and about the same amount too. So I try to keep it as consistent as possible. So here you can see it's all set up, ready to go. So then I started the experiment. I started pouring in water, and you can kind of see this was the immediate look after I poured in the water. It was hard to see the liquid unless I got a lot closer with the compost one and the plant one. The water drained a lot quicker and came out and was a lot dirtier with the one where it was just the soil itself. This soil was kind of loose, but it wasn't sandy loose. I know there's more technical terms for it that I don't know off the top of my head, but this one was just like in the video that was provided. It came out the quickest and the dirtiest, and you can kind of see the results here in the pictures on the right. Now you will notice that just like the video, this is the dirtiest, and it kind of got clearer as you went, but this is still a little dirty. It's because I had to cut the soil. There is some loose particles instead of growing the grass in the container. So that's why this got a little bit dirtier. And one of the things I had to kind of modify as I went was putting something underneath the backs of it, because like I said, this one drained super quick, but the others took a while. And for time constraints, I kind of sped the process along, which the board worked pretty well. I tried the stick, but it just wasn't flat enough, too many rounded surfaces. And then I was able to find a board that worked a lot better. So the standards I decided to align it with was the steel standards. You'll see here these are the two that connected with me immediately. Was the earth materials and systems. We're developing a model to describe ways the geosphere, biosphere, hydrosphere, and even just depending what grade or the evidence that affects weathering or the rate of erosion by water, ice, wind, or vegetation. So this one kind of connected with me right away. And also I think the natural hazards comes into play. I think there's a lot of other standards that could easily be brought in depending on how the experiment is done in class. And that kind of takes me to my connections among the STEM practices from Vasquez's book, page 38. I highlighted the ones that I felt connected with the part that I did. I think in the classroom, I would add a little bit more to it, and that would encompass the bottom. So that is my engineer design process for the erosion bottles. Thank you.